All right, let's jump right in. We're going to talk about a totally new way to think about AI that writes code. We've all seen it happen. It's pretty magical, but let's be real. The code it spits out isn't always perfect. So what if an AI could actually think through its plan, just like a person, before writing a single line? Well, that's exactly what we're looking at today with a new framework called CODESIM.
You know the feeling, right? Anyone who's used an AI coding assistant has been there. You get this block of code, you're excited, you run it, and it just falls over. Or maybe even worse, it runs, but the answer is just plain wrong. So why is it so hard for these incredibly smart AIs to get it right the first time?
So here's the deal. The research points out that most AI systems today just kind of guess. They generate a first draft and hope for the best. And when it fails, they get stuck in this loop of testing, debugging, testing again, and it's super slow and expensive. The whole process really hinges on that first draft being good, and that's a massive gamble. And this is where CODESIM comes in. Researchers have built this new framework that takes a completely different path. It's an approach that's actually inspired by how you and I work as programmers. The big idea? Simulate the solution before you even start coding. So what exactly is CODESIM? Well, think of it as a team of AIs working together. But the secret sauce? The real magic here is simulation. Just like a developer would sketch out an algorithm on a whiteboard or just run through it in their head, CODESIM simulates its own plan to see if it even makes sense. And it uses that same trick to debug its own code later on. Okay, so let's pop the hood and really understand this framework. How does it all fit together? It all comes down to a team of 3 specialized AI agents working in concert. And here it is, the whole pipeline. It's a 3-step dance. So a problem comes in, and first it hits the planning agent. Once that plan gets a thumbs up after being simulated, it gets handed off to the coder. Now, if the code from that agent fails any tests, it doesn't just give up, it goes to the debugger. The key thing to see here is that this is a loop. It's a constant process of reflection and refinement until the code is perfect. So let's quickly break down their jobs. First, you've got the planner. Think of it as the architect. It creates the blueprint, the strategy. And this is the important part, it simulates that plan to find any logical holes from the get-go. Once the plan is solid, the coder steps in. It's the builder translating that verified plan into code. And if things go wrong, the debugger is the inspector, simulating the code against the exact test it failed to find the bug and fix it. And this quote from the paper, it really nails the whole philosophy. CODESIM is built to mimic how we humans think. We visualize, we run through steps in our head. That's what makes this step-by-step simulation so different and so powerful.
So let's look at this in action. This is the plan validation stage. The AI comes up with a plan for a pretty standard Fibonacci sequence. But watch this. When the planner simulates its own plan, it realizes the logic is busted from the start. It catches that fatal flaw before a single line of code is written. It forces itself to go back to the drawing board. That's what you call proactive.
And that same superpower, simulation, gets used again for debugging. In this case, the code fails because it's checking for even numbers when it should be checking for even digits. A subtle but critical bug. Instead of just guessing, the debugger simulates the code on the exact test case that broke it. It follows the logic step by step, finds the precise error, and fixes it. It's like a surgical strike on the bug. Okay, the theory is fantastic. It sounds smart, it sounds human-like, but does it actually work? Does all this thinking before you code actually lead to better results? The researchers put it through its paces.
The answer? Oh yeah, a huge yes. On the really popular Human Evolve benchmark, CODESIM, powered by GPT-4o, scored an incredible 95.1% accuracy on the very first try. That's not just an improvement, that's a new state-of-the-art record.
And this wasn't just a lucky shot on one test. On another major benchmark, MBPP, it hit 90.7%, again blowing past all the previous top-performing methods. Now, this table is where it gets really, really clear. Look at this. Using the exact same base model, GPT-4o, just prompting it directly gets you about 90% on Human Eval. The previous champ, MapCoder, gets the same. But look at CODESIM. It jumps all the way to 95.1%. That 5% leap is massive at this level. It proves that the framework itself, the way it thinks, makes all the difference. And if we dig a little deeper, this chart is really telling. It shows how CODESIM stacks up against other methods as the problems get harder. And you can see that as you move to the really tough competition-level problems, other methods start to fall off. But CODESIM's performance stays incredibly strong. This thing doesn't just solve easy problems. It excels when things get complex.
Okay, so the numbers are impressive. The tech is cool. But let's zoom out. What's the big picture here? Why does this really matter for the future of AI?
So here are the big takeaways that make this a genuine breakthrough. 1, it just flat out beats everything else out there by a lot. 2, it's actually more efficient. It uses fewer tokens, which means it's faster and cheaper to run. But most importantly, it establishes simulation as this powerful new tool for AI. This idea of thinking before acting is a huge paradigm shift. And get this, the performance can be pushed even higher to a crazy 97.6% with a little extra help. The researchers think this whole approach could be used for other tough domains like high-level mathematical reasoning.
When you put all this together, the performance, the efficiency, the human-like logic, it leads to a pretty mind-bending question about where all this is going.
Just let this one sink in for a second. If an AI can create a plan, check its own work, find its own flaws, and fix its own mistakes with this kind of reliability, are we looking at the beginning of a truly autonomous AI programmer? A fascinating and kind of wild thought to end on. You know, speaking of debugging things to get a better outcome, if this explainer helped you sort through the logic here and get a clearer picture, I've got a lot more where that came from. Seriously, for more explainers that cut through the noise on topics just like this one, head over and subscribe to VibeDoc on YouTube. You'll be glad you did. Thanks for tuning in.